Hello everyone, myself Shubhajit. I hope you guys are doing good. In these and upcoming videos, I will be discussing about some of the silly mistakes in physics that I committed during my JEE preparation. These are not calculation mistakes, of course. These are basically conceptual mistakes. I call them silly mistakes because you all know the concept, but to get these questions correct at the exam pressure, you must keep those concepts in your subconscious memory. So without further ado, let me start solving this question. I hope you have read this question one time. This question is taken from SBT but modified slightly. I have added how to find the time period of oscillation. So before that, we need to find the condition for equilibrium. So the two charges are in equilibrium for some particular value of theta. So for that, what we need to do is, first of all, we need to balance the torque about the center. So that is quite easy. So for some angle theta naught, if the system is in equilibrium, then we can obviously write this equation. So the charges are q and q dash. So from that we will get that tan theta naught equal to q dash by q. And we also have to balance the translational equilibrium. We also have to write the translational equilibrium equation. So for that, q plus q dash into E, and notice that we are already given the value of E in the question, 4 mg by 7q. So if we substitute 4 mg by 7q here equal to mg, so there we can solve and get the ratio of q dash by q. So we will get that tan theta naught equal to 3 by 4. So tan theta naught equal to 3 by 4. So approximately it is 37 degrees. This is not a small angle, of course. Now what we will do is to solve for the SHM condition. One method is to write torque equation, or one more method can be to write energy equation. And if we write solve by the energy method, if I denote energy by E, to find SHM condition I have to take the derivative of energy with respect to time and equate it to 0. So at any instant, if this it makes an angle theta, if this is the angle theta made, q dash, and suppose it is rotating with angular velocity omega. So if we observe carefully, the point charges do not have mass by itself. The mass is concentrated in the ring. So one form of energy will be the kinetic energy of the ring, that is half I omega square. So half moment of inertia is mr square into omega square. It is the kinetic energy, and one more energy will be the potential energy due to these two charges, k q dash divided by root 2r. This separation is root 2r. And some more forms of energy will be that see, as these charges are moving, so as the ring rotates, the position of these charges are changing. So this ring is not changing, this ring is static, it is just rotating in its place, but the position of the charges are also rotating as they are fixed to the ring. So as the direction of electric field is in this direction, there will be also one kind of energy, that is potential energy, associated with this electric field. We can also relate it like that. See, for example, gravitational field is here. If the mass m is, if for example in another question, independent question, there is a mass m and there is a gravitational field like this, we define potential energy with respect to this datum level as mgh. So by similar logic, we can also define the potential energy here. If we consider this datum level here, so we can write it as minus QER, and we have to take the cos theta component, and minus Q dash ER sin theta component. Like this vertical height I am talking about, what this vertical height will be according to that, and just adjusted the minus sign because the direction of E is opposite to that. So if we do that, so this is the energy that we get, and if we take its time derivative and equate it to 0, the time derivative of E and equate it to 0, that time we will get the required equation that will give us the SHM condition. So that will give us mr square omega then theta double dot plus QER sin theta omega. This is very simple, you all can calculate it. The main concept comes after this point. So equal to 0, when we cancel omega, we will get a equation that will give us the condition of SHM. So we will get that theta double dot equal to mr minus QE sin theta plus Q dash E cos theta. Right, so this is the equation that we were getting. Now many can commit a mistake that we generally remember it like this, that theta dot equal to minus omega square theta. So, or if some cases the theta is not the mean position, we write theta minus theta mean. So, and we write like this is the angular frequency. So we can write time period as 2 pi divided by this capital omega. So this we all know. And now I am writing what is wrong in this. So the thing that is wrong, let me write it properly, that it is wrong. We cannot do like this. Many might commit the mistake that they will write sin theta approximately equal to theta and cos theta approximately equal to 1. Cos theta they will take as 1 and sin theta they will take as theta divided by mr. So now they are getting some theta mean. They will think that this is theta mean sort of thing. They will take it common and then think that it is some kind of theta mean, and then they will get that minus QE by mr, theta minus theta mean. So they will think that this is omega square. So time period is 2 pi by omega. But this is wrong. Why it is wrong? Because here sin theta is not small. So when theta is not small, we cannot approximate sin theta to be equal to theta. Since here theta is not small, we are doing something wrong here. And the equation of SHM, like theta dot equal to minus omega square theta, here theta is the small displacement from the mean position, but small angular displacement from the mean position, whatever say. It is not for defined for large displacements. Like see, here it is in equilibrium for tan theta equal to 3 by 4. So when tan theta equal to 3 by 4, it is in equilibrium, and after that, when we slightly displace it, for that theta, for that small displacement only, it will perform SHM, not about the mean position. It will not perform SHM about theta equal to 0, because it is not in equilibrium about theta equal to 0. It is in equilibrium about theta equal to tan inverse 3 by 4. So the correct way to solve this is to use calculus. Like, it is the best way. We all know that f of x naught plus delta x equal to f of x naught plus f dash of x naught into delta x. Now this thing is known to all, but the point is that we need to keep this in mind subconsciously. Like, if someone tells us, then we can directly tell that it has to be done by this way, not by thinking once, because in exam pressure this may not click to many. So we have to keep this in mind, that in these kinds of questions there is a trap and we cannot fall into that trap. We have to use calculus to derive this. So using similar logic, we can write sin theta as sin theta naught plus cos theta naught into delta theta, small angle theta, and we can write cos theta as cos theta naught minus sin theta naught into delta theta. Now the equation that we get here we have to substitute this. So upon substituting, we will get this expression, that is, I am not solving the intermediate steps, so you can easily check that we will get this expression, minus by 5 mr. The cos theta sin theta terms will cancel out accordingly, and we will only get this expression. Now this is the infinitesimal small displacement from the mean position, delta theta. So now we can say that this whole term is omega square. As this whole term is omega square, our final answer will be time period equal to 2 pi divided by omega. So 2 pi divided by 5 mr, 2 pi into root over 5 mr divided by 4q plus 3q dash into e. So this is the answer to this question. And the major takeaway is to use this formula and not directly write sin theta equal to theta. It is not always equal to theta, and not in this case, because theta is not small in this case. So this was the major takeaway. I hope you learned something new in this question. See you guys in the next video.